So the left-hand side is fine. 12 minus 6x over x plus 2x minus 2. I bring over a 3x over x plus 2. And then positive 3 minus 2x over, instead of this, I have negative x plus 2, so now I'm going to write negative x minus 2 and leave it alone for a moment. Do we understand each and every step? So I moved this, it was positive, so it has to change to negative. I moved this, which was negative, I had to change to positive, and I had to rearrange this and factor out negative 1. Very good. Now one more step and then I'll find the least common denominator. The top here is positive, the bottom is negative, so this must change into negative. So 12 minus 6x over x plus 2. X minus 2 minus 3x over x plus 2, and minus 3 minus 2x over x minus 2 equals 0. And now I will write the two restrictions. Make sure you do not change the expression into the equation into an expression. One more thing I want to mention here is you cannot have more than one equal symbol in each equation. You cannot combine like terms and say equals and then equals and then equals and then 0. You cannot do that. As you see, each equation is on one row with one equal symbol. A left-hand side, one right-hand side. One row, left-hand side, equal symbol, right-hand side. Left-hand side, equal symbol. Okay, good. Restrictions, please.
Plus minus 2.
Good. So then you're saying that the least common denominator must be this. So now the adjustments for each fraction. You understand it will be a terrible mistake for you to write 12 minus 6x minus 3x minus 3 plus 2x up here. That would be a terrible mistake because they don't have the same denominator. They have to be changed into something over the least common denominator. So what does the first one need? 1. The second one. And the last one, exactly what it does not have. Very good. So now the top is 12 minus 6x. But now careful, I have to distribute negative 3x to these two. So negative 3x squared plus 6x. And now careful, have minus and I have to distribute 3 times x with minus. 3 times 2 with minus. This changes the sign, so 2x times x plus 2x squared and plus 4x. Sorry, I ran out of room again. So now I'm trying to combine like terms. So I have this and this. So this is negative x squared. Then I have these two go away. And then I have 4x minus 3x, which is plus x. So these are accounted for. And then I have a 12 minus 6, which is positive 6. Let's see if there is anything else left. No. Over x plus 2, x minus 2 equals 0. You can write 0 over 1 or just think. It's a fraction. When can a fraction be 0? Only when the top is 0. This is quadratic, and you know me, I refuse to solve a quadratic equation with a negative leading coefficient. Now this is more human, and I will factor. And how do I factor? I factor into x minus 3, x plus 2, and I get two options, 3 and negative 2. And you should say not so fast, because of this. So what do I conclude? Only x equals 3. Any questions? Now choose a C or D for you to work on for 1 minute. And I can give you paper if you want. You want paper, pencil? If you do. Thank you. So let's choose one. You either want C or D.
I'm doing D.
You're doing D? Okay, so let's do D then. So 1 over x minus 3 minus x minus 4 over x squared minus 9 equals 1. After this, I would like to look at some literal equations and then complex rational expressions. Ready to work on this together? Okay, so here's what I would do. 1 over x minus 3 minus x minus 4 over x plus 3, x minus 3, minus 1 over 1 equals 0. I will state that x cannot be plus or minus 3. I will find the least common denominator as x minus 3, x plus 3. I will say this needs an x plus 3, this one needs only 1, and this one needs the product. And I will write the product here because it's easier for me to distribute. So now x plus 3 minus x plus 4 minus x squared plus 9. These two go away. So then I have negative x squared, and this is 7 plus 9, which is 16, over x minus 3, x plus 3. You don't have to change it into a proportion. A fraction is 0 only if the top is 0. So then I have negative x squared plus 16 equals 0, or here's one way of writing it, solving it, because I know 4 methods. So x equals plus or minus 4. Are they on the list? No. Any questions? I think we should solve part C as well, problems in part C, and then move on. Is that okay? Mike, did you catch the error and corrected
I
it?
just had my 4s and minus 4 instead of plus 4.
Okay, so is it clear now?
Yes.
All steps? Perfect. Yep, it's very easy. Very easy. That's why, although I know you understood it, you still need to practice a lot because it's not going to be good enough. Okay, 5 minus 3x over x squared plus 4x plus 3 minus 2x plus 2 over x plus 3 equals 3 minus x over x plus 1. One minute. Ready? Okay, so here's what I would do. 5 minus 3x over x plus 1, x plus 3, minus 2x plus 2 over x plus 3, minus 3 minus x over x plus 1 equals 0. I will state two restrictions, not negative 3, not negative 1. I will write x plus 1, x plus 3 as the least common denominator. I will find the adjustments. 1, x plus 1, x plus 3. And carefully work on the numerator now. The first one is nice and clear, 5 minus 3x, minus 2x times x, minus 2x times 1, minus x times minus 2 times x, and minus 2 times 1. Minus 3 times x, minus 3 times 3, positive x times x, positive x times 3. Sorry, I ran out of room again. Are these okay?
Yeah, I'm fine.
Okay, so now I see x squared and x squared, so this is negative x squared. Then I see a negative 3x with a positive 3x. It go away. A negative 3x with the other negative 2, so it's negative 7x. So these are accounted for. And the only thing I have left is a 5 minus 2, which is 3, and minus 9, which is negative 6, over x plus 1, x plus 3 equals 0. Did we get this? A tiny little thing messes up the whole. Yeah, I agree.
And I was gonna do it again because I mean I can't
Right.
factor.
Yes. So factoring is not necessary right now. We can use the quadratic formula, but we expect them to be factorable. A fraction is 0 only if the numerator is 0. Negative x squared minus 7x minus 6 is 0. Of course, I will multiply by negative 1. And of course, I will factor and 1 and 6. And I will get two options, x equals negative 1 and x equals negative 6. And you can say, not so fast.
So negative 6.
Yes. Only. So not difficult, but intense, right? It's intense. You have to be careful at each and every step.
It's good. When we did the square roots, we have to multiply those
Right.
roots. Now it's like
Yes. If you remember the first day of classes, I said two topics are difficult, I think, in this course. One is this solving radical equations, and this is the second. Why is it difficult? Look at how many steps and how many different things you have to worry about. First, you have to factor. You have to know how to factor. Secondly, you have to move this term if you are using this method. Then you have to be able to find the least common denominator, be able to state restrictions, be able to multiply by the tops by the necessary quantities, be able to distribute everything in here and then combine like terms into this. Then say, okay, a fraction is 0 and the numerator is 0. Then solving a quadratic equation, multiplying both sides by negative 1, factoring, going back and checking up. It's a long process. Okay, now I would like to look at these types of equations in which we are asked to solve for a particular letter, just one, and they indicate which one. So let's choose. Let's start with B. So we have a A equals 1/2 multiplied by H multiplied by A plus B, and we're asked to solve for this. That's the letter that they want us to solve for. So, what should I do?
No clue at all.
Multiply both sides by 2. I don't like fractions. Multiply by 2, so 2a equals H, A plus B. We're solving for A. What else do you want to get rid of?
H.
Yes, I will divide both sides by H, so I have 2a over H equals A plus B. Again, I'm solving for A. Final step.
Negative.
Sure. Move B to the other side. So A equals 2A over age minus B. That's it. Let's look at another one. Any questions from me? So we are solving for P. So we have A equals P plus PRT, and we want to solve for P. These are all sorts of models from economics, from physics, from chemistry, from accounting, from whatever, biology. Okay, so I can't. I'm solving for P. There are two terms, exactly. There are two terms that have P and I cannot combine them. Then what do I have to do?
You can move either the
If I do, it's not going to make any difference. A minus P equals PRT.
now A minus P divided by R. Let's see.
I can't
Why not?
because I have two variables in there.
Would you
What is the keyword in this class and in this chapter?
divide by RT?
I can't.
No.
If I cannot combine two terms and they have the variable, what do I do?
Move on to the next one.
No, not acceptable. What is the key word here? Exactly. I have to factor out P. Of course. It's my only chance. And then how do I solve for P? That's it. So when I have two terms or more that I cannot combine and I'm interested in a particular variable, I have to factor out that variable that I'm interested in. Like here, I have to factor out P. There's no other way. Ready? Okay, let's look at also 1 over R equals 1 over A plus 1 over B. We're asked to solve for A again.
Denominator R, A, B.
So what I would do here, because this is the only variable these two are not, I will move 1 over B only to the other side. I'm not changing the rules on you. But this is the only variable. When all fractions, or at least two of them, have the same variable and no other variables, then I will not do this, right? If I have A here, and A here, or just one variable, I will move everything to one side and set equal to 0. But this is the only variable. These are considered to be known, like numbers. So that's why I moved to the other side, only 1 over B. So now I find the least common denominator. What do I get? Of course, this must need a B and this must need an R, so B minus R. And now, in order to solve for A, what should I do? What type of rational equation is this? That's it. So BA times B minus R equals RB. How do I get A? That's it. Really, the last topic of this semester is this. Nothing new. I just need to show you a couple of examples, and you'll see in a moment why I say nothing new. Okay, so let's look at least two of them, like B, 1 plus 3 over x minus 18 over x squared, and everything divided by 21 over x squared minus 4 over x minus 1. Okay, these are called complex rational expressions. Why? Because they have operations with fractions at the top and operations with fractions at the bottom. That's all. It sounds like it's difficult. but it's not. Okay, so focus on the numerator and please give me the least common denominator. Forget about the denominator for a moment. What is the least common denominator in the numerator? Exactly. And now, tell me the top. What does it need? The top of the first one needs x squared. The top of the second one needs, indeed. And the top of the third one needs 1. One more time, you understand it would be a terrible mistake to write at the top 1 plus 3 minus 18. That would be a terrible mistake. Okay. So then, can anyone give us the numerator? Good. So now forget about the numerator. Let's focus on the denominator. And let's find the LCD for the denominator. Good. So now let's find the adjustments. The adjustment for the first one, for the second one, and for the last one. Perfect. So now can anyone give us the numerator now for the denominator? 21. That's it. Perfect. Excellent. Very good. So, yes. But now at this point, I will do this. And yes, we have to rearrange everything in there. So first, I will write x cannot be 0. And I will copy the fraction from the top, factoring the numerator. Can anyone give us the factored form of the numerator? Yes, x plus 9. I'm sorry, x plus 6. And x minus 3. Very good. Good. And then times x squared over, and now I have to fix this as you said, negative x squared plus 4x minus 21. These are two fractions that are divided. The top gets copied and the denominator gets flipped. Now I have to factor the denominator. I am allowed it because this is a product and I already stated the necessary restriction. I can do this. These can go away. So then I have x plus 6, x minus 3. I can put the minus in front, this negative in front here. And then I have to factor this into x plus 7 and x minus 3. I have to add to this restriction. I have to add not negative 7 and not 3. And now I'm free to simplify. And I will simplify what? X minus 3 by x minus 3. So the answer is negative x plus 6 over x plus 7, assuming all these conditions are fulfilled. Is that okay? Is that okay? Okay, let's work on one more. Let's say x plus 2 is the next one, minus 12 over 2x minus 1, and everything over x plus 1 minus 9 over 2x minus 1. Let's work on this, and this is the end of new material. No more, nothing else, that's it. So let's work on this for 1 minute. And I will put my attendance in. Okay, ready? We need more time? Okay. Okay, ready? So the least common denominator for the top is 2x minus 1. And for the bottom, 2x minus 1. You can consider this as one term, or you can consider it as two terms, the same thing. You'll get the same thing no matter what. So x times this, 2x squared minus x plus 4x minus 2 minus 12. So 2x squared minus x plus 4x minus 2 and minus 12. Same thing with the bottom, 2x minus 1, 2x minus 1, 2x squared minus x plus 2x minus 1 minus 9. Of course, x cannot be 1/2. So the numerator is 2x squared plus 3x minus 14 over 2x minus 1 times 2x minus 1 over 2x squared plus x minus 10. Ready to continue? These two will go away. However, I still have to state restrictions for this, but after I factor it. So now the numerator, 2x squared plus 3x minus 14. I'm looking for two numbers whose product is negative 28 and whose sum is positive 3, and they have to be 7 and negative 4. So therefore, this is 2x squared plus 7x minus 4x and minus 14. So I have x and 2x plus 7 and minus 2 and 2x plus 7. So I know this is 2x plus 7 times x minus 2. That's for the top. I repeat for the bottom. So this is 2x squared plus x minus 10. And I need two numbers whose product is negative 20 and whose sum is positive 1, and they have to be 5 and negative 4. So this will be 2x squared plus 5x minus 4x minus 10, which is x, 2x plus 5 minus 2x plus 5. So this is 2x plus 5 and x minus 2. So now I can go back. I can state two more restrictions. X cannot be negative 5/2 and 2. X cannot be negative 5/2 and x cannot be 2. So finally from here, I continue here. So the top was 2x plus 7 times x minus 2, and the denominator was this, which is 2x plus 5 and x minus 2. The only thing that goes away. and then 2x plus 7 over 2x plus 5. Assuming all restrictions are fulfilled, which are these. A lot of work, a lot of steps in this one. Okay, now I would like to, we have about 20 minutes. I'd like to go back to whatever else you want me to. Do you remember what was that?
Only one exercise with log with the other hand.
So equations, you mean, or equations with natural log? Okay, so let's go back to chapter 12, the end of chapter 12. I recommend select problems from the end of chapter 7, all review problems to make sure that, except word problems, there was one section that we had to skip because it's not in the syllabus, not because I wanted to skip. Okay, so I'm going back to chapter 12, at the end of chapter 12, the review. Okay, so we want to so is it something like this you meant, like 89 on page 774, like natural log of 2x minus 3 equals -1, solve the equation? Is that what you meant? Okay, good. How do I solve this equation? It's a log equation, and my only chance is to change it into an exponential. What is the base of log? Ln. That's log. Base e. Yes. E raised to -1 equals this. E raised to -1 equals 2x minus 3. Normally, we should have started with 2x minus 3 greater than 0, because that's a restriction here. So x must be greater than 3/2. So if the solution is not greater than 3/2, it cannot be accepted. Also, you can go back and check if that's what you want to do. I prefer stating restrictions, then going back to check. So e to -1 is 1 over e plus 3. I have to move 3 to the other side, and this is 2x. And then I will divide both sides by 2. So x equals 1 over e plus 3 over 2. This is a number greater than 3/2 because this is 3 over 2 and we have a little bit extra in the numerator. So this is a number greater than 3/2, and this is the solution. Anything else from this?
With x as an exponent.
Yes, you mean exponential equations?
Mm-hmm.
Okay, very good. So let's look at, yes, let's say 36 on page 7733. 8 raised to 3x minus 2 equals 4. So what do we do? How do we solve this equation?
You said 2 squares of 2.
So 4 can be replaced by?
2 squares.
Yes, and 8 will be replaced by? Very good. Excellent. So now I have to copy the base. And what happens to these exponents? Yes. So 9x minus 6 equals 2 squared. So then two numbers are equal and they have the same base. What has to happen? Two numbers are equal and they have the same base.
Set them equal.
The exponents have to be set equal to each other. Very good. So then 9x equals 8 or x equals 8 over 9. For exponential equations, there is no restriction. Good. Anything else?
Another one of these.
Like this? Okay, very good. So let's take a look. 33. 2 raised to 3x equals 1 over 16. We cannot use 4 because 4 is not a prime
We
number.
have to find the same base.
Yes, 2 to 3x equals 2 to which power?
Four.
Thank you. So again, two numbers are equal, they have the same base. Therefore, 3x must equal -4, so x must equal -4/3. Anything else?
When they ask to graph, and it's 1/3 elevated to x.
Oh, when you want to graph an exponential function. Okay, very good. Which exponential function? Very good. Good. So we need a domain. What is a domain of an exponential function? Is it a friendly function or not? Good. Exponential functions have no restrictions. So now let's plug in -2, -1, 0, 1, and 2. And let's see what we get. When the exponent is negative on a fraction, the fraction has to be flipped.
It would be 9.
9. And -1. 0.
0.
No.
Oh,
Any number raised to 0 is
it's 1.
1. Perfect.
And then 1/3.
Yes?
And
Perfect. Which way are we going? Which direction is this?
it's kind of like
110.
Yes, which is? If I divide $1 to, and I want to give to infinitely many people out of it, how much will you get from it?
Okay. 0.
And this way?
Okay.
Yes. So let's graph this function. -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, 0, 1, 1, 1/3, and so on and so forth. It does not touch the x-axis unless we say eventually. It may. Very good.
with love.
With what?
With love. And also
Yes, yes. So what do you would like to do with that? You want to,
I don't remember exactly. Yeah, just anything with love. What do you usually do with love?
word problems, graphing, solving equations like we just did.
Solving like we did with the
Yes. Okay, very good. So let's look at log base 4 of x squared minus 3x equals 1. So how do I solve this equation? It's a log equation. I have to change it into
we said the base is 10.
the base is 4. If the base is not written and I have log, then the base is 10.
Okay.
If the base is not written and I have ln, then the base is e. So for this, the base is 10, and for this, the base is e. But if the base is written, I cannot change that. Good. How do I replace this? The base raised to 1 equals x squared minus 3x. Base raised to this equals this. So then x squared minus 3x minus 4 equals 0, x minus 4 and x plus 1. And I get two options, 4 and negative 1. Not so fast, because this is a function with restrictions. It's not a friendly function. You either stay the domain and solve, or you go back and check. 4, 16, 16 minus 12. Yes, this is a positive number. 4, so what was it? 16 minus 12, it's 4. 4 raised to the first power is 4. That's correct. So 4 is acceptable. Now let's check negative 1. So 1 plus 3 is 4. So this is 4. 4 raised to 1 is 4. Acceptable as well. Anything else?
I'm good. And I can take the test next Wednesday? This
Yes.
Be the last day to take it?
Yes. Yes. Yes.
And that'll be, this is our last class?
No, we do meet on Wednesday.
Oh, okay.
We do meet on Wednesday. Wednesday next week will be the last class for us, and the following week the final exam. So the last class I want to review.
We meet in the next
Wednesday, and that's it.
What are we gonna do next Wednesday?
Review for the final exam. There is nothing new.
Okay.
We're done with new material.
And then the next one is gonna be the final. Next Wednesday after.